Hey everybody, just checking in. Today you are going to be looking at notes 1.04. And at the beginning here, we're going to do a little bit of review of quadratics and factoring. We're going to need those skills this year for geometry so that you don't lose them between your algebra course and your possible algebra 2 course you'll go to next year. So let's get started. Mixed solving quadratics practice. In an effort to review algebra topics, we're going to do some mixed quadratic review. Right. Directions say solve for all values of x. All values, meaning when we have an x squared, like x squared equals 121, there will always be two values of x for our answer. So a little hint I have here is to factor and solve. So remember when we have an equation, ax squared plus bx, sorry about that, ax squared plus bx plus c equals 0. We can factor it into two binomials and then use our t-chart to kind of solve. Or if it's a nice simple one, we can just take the square root of both sides. So looking at letter A, we have x squared equals 121. How I'm going to solve this is by taking the square root of each side. X squared is isolated by itself, so we can undo a squared by taking our square root. X will equal positive and negative 11. So again, remember we have two answers. Now for the most part, we're going to be taking the positive version because we're in geometry class and we're going to be looking at measures of angles or lengths of segments. So we're going to need positive values because you measure segments in positive numbers, not negative numbers. Moving over to number 2. Here we have a trinomial. X squared minus 5x minus 24 equals 0. And what we have to remember is we need to decide what multiplies to 24 and adds to negative 5. And I'm going to pull up our graphing calculator. Okay. So if you had Miss Hopkins and I, or if you had Miss Austin last year, one of the cases we looked at is we want to know what multiplies to negative 24. I'm going to take the rest of this purple stuff out of here for a second. Okay. What multiplies to negative 24 and what adds to negative 5. So Miss Austin might have done a little number puzzle. Negative 24 goes in at the top, negative 5 down here. And what we do with that is we go to our y equals button. So in your graphing calculator, we go to y equals here, and we're going to type in negative 24 divided by x. And when we go to our table, so if you hit second graph, it brings up your table of values. And these are your factor pairs, 1 and negative 24, 2 and negative 12. We're going to go down to this third one here is 3 and negative 8. Okay, so if we double check it, is 3 plus negative 8 going to add to our negative 5? So 3 plus negative 8 gives us negative 5. So our two factors are positive 3 and negative 8. Ooh, didn't need to jump that over. So when we go to factor, we're going to have our double bubble. Remember, x is going to go at the beginning of each, equals 0. Now this order doesn't matter. You could put the 8 over here and the 3 over there, but the signs do make a difference. So positive 3 is in the first, negative 8 is in the second. If we draw a little t-chart, we set each factor equal to 0. So x plus 3 equals 0. We subtract 3 from both sides. X will equal negative 3. So it's one answer subbed back in would give us an answer of 0 back to the original equation. The other answer, x minus 8 equals 0. We add 8 to both sides, and our answer is x equals positive 8. So those are two values of x that would make this equation true. So again, when you have an x squared, there should be two values of x. Now, both of those equations were already kind of set up for us. We didn't have to change them at all. But looking down at letter B, remember, we need to make sure an equation equals 0 first. So here we have x squared equals 18 minus 7x. Now we're going to move the 18 and the 7x over to the other side because we don't want x squared to be negative. Erase that there. Here we go. So if we add 7x across and subtract 18, whatever we do to one side, we have to do to the other. So this other side's going to say x squared plus 7x, because we like to have our x term second, minus 18. So when we go to rewrite, and that's just to keep it balanced, right? We added 7x and subtracted the 18 from this side, we had to do it over here. So our trinomial is going to read in standard form x squared plus 7x minus 18 equals 0. And in this case, we have to multiply to the 18 and add to the 7. So again, what multiplies to a negative 18 and adds to a positive 7, we can go to our graphing calculator, go into our y equals button. Instead of negative 24, we're going to put in negative 18 divided by x and go to our table. And here we have, I believe it's going to be a 2 and a 9. Now 2 and negative 9, same signs, different signs, different. We're going to keep the sign of the negative 9. So I think a 9, positive 9, and a negative 2 work better to make us a positive 7 there. So again, our two factors would be x plus 9 and x subtract 2. And again, just to double check, 9 times negative 2 does give us negative 18, and 9 subtract 2, if we're adding them, does give us a 7. So our t-chart here becomes x equals positive 9, x equals, my mistake, x plus 9 equals 0. So in that case, x plus 9 equals 0, and we subtract 9 from both sides. So x equals negative 9. Sorry, I have a little lag on my laptop today. And x will equal 2. We really just changed the sign, move in there, because we set it equal to 0. Letter D is a challenge question. Okay. 8x squared plus 14x minus 15. That number in front of x squared, that 8, tells us that this is p's and c's factoring. If you remember that from Miss Austin's class, Miss Dobkins and I did not teach this type of factoring. But when that coefficient, that number in front of x squared, is larger than 1, how we solved this for the most part last year was to use the quad formula. So if you'd like a little extra credit and to try that, the quad formula, remember, reads x equals negative b plus or minus a square root of b squared minus 4ac all over 2a. And our a, b, and c values would be a is 8, b is that middle term in front of x, is 14, and c is the number at the end, is negative 15. So if you'd like to try it and find the fractional form of your questions, you can. We don't have to. We're not going to get to that level right now. But if you're a student who'd want to go on to Algebra 2 and get your Advanced Regents Diploma, we'll be coming back to that a little bit later this year. Okay. Starting into our notes for today. Today we're going to be diving more into midpoint. Last class we talked about midpoint. It was a quick definition in your notes that if you had a midpoint here of a segment, it divides your segment into equal pieces. So that's what the definition at the top of our page reads. And given a diagram, right? So O is the midpoint of DG. Those are just words right now and symbols. What we can do is make a diagram of that. O is the middle of segment D to G. So if we start with the big segment DG, we can kind of estimate the middle to be point O. So we have segment dog, where DO from D to O's length would measure the same as O to G. So our statement here would say that DO as a segment is congruent to OG. And we know that's true because the definition of midpoint tells us that. Now this box here, see how there's like the 3 columns there? These boxes we're going to use a little bit later in our proofwriting. And proofwriting is our math essays. So in math class, we have essays, kind of like you have a argumentative essay or a DBQ you might write in your English or history classes. We have math essays we're going to be doing this year in geometry. So that's just a little prelude to what's coming. Looking at a few examples with our midpoint. Given A is the midpoint of PT, we're going to start with a picture. So as we read the words, we need to kind of formulate a diagram in our heads. Writing it down is helpful. So A is the midpoint of PT. So we know PA and AT are equal. If PA is represented by x squared, AT is represented by 16. So what we're going to do here is we're going to set those two pieces equal. So since PA and AT are equal, we're going to set them equal. So x squared equals 16, and we can solve for x by taking our square root of each side like we just practiced on the warm-up. So x equals, now remember, we always have two answers, plus or minus 4. But for our case, can this length be a negative 4? No. So we're just going to keep it safe and just accept the positive answer here. So find the value of x would be 4. Moving down to number 2. A is the midpoint of CT. So here we're going to have segment cat. So C is at one end, T is at the other, segment CT. A is the middle piece. If C to A is represented by 3x plus 18, and AT is represented by x squared. Again, those two pieces are equal. Now, when I set up the equation, I love my x squared to always come first. It stays to my left. It's easier to factor this way. So I'm going to say that AT, the x squared, equals 3x plus 18. And this is similar to exercise 2 from the warm-up. What we have to do here is subtract pieces over and set our equation equal to 0. So here we're going to subtract 3x from both sides and subtract 18. So whatever we do to one side, we do to the other. And again, kind of imagine your line down the middle. So this side will read x squared minus 3x minus 18 equals 0. So what multiplies to 18 and adds to 3 is going to be 6 and 3. So in your double bubble, you have x minus 6, x plus 3. So negative 6 times positive 3 multiplies to make negative 18. Negative 6 plus 3 is negative 3. So here x equals 6 is one answer. X equals negative 3 is the other. Now again, I'm going to be keeping our positive values here. So taking 6, they ask for the measure of AT. Well, 6 squared is 36. Okay. If I took negative 3 in here, it technically does give me a positive answer. So negative 3, remember, squared does equal 9. And when we put negative 3 into here, it would equal out to be the same. But again, we're going to take the positive answers for now. Okay. Extending into the coordinate plane. So you have graphed points all along middle school and into freshman year, or algebra last year, I should say. We are going to also extend these ideas besides just a diagram we kind of draw on our paper. We can plot the points in the coordinate grid. So looking here at example 3, I'm just going to zoom in so I can draw my graph. Draw a segment AB given A is negative 4, 3, and B is 6, 7. So from the origin, remember you go X direction first, Y direction second. I know it's been a while. 1, 2, 3, 4 to the left, 1, 2, 3 up. We can plot point A. Point B is 6, 7. So 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4, 5, 6, 7. It's going to be right there. Okay. And I just used a straight edge to connect my 2 points A and B. Draw a segment AB. Okay. Now what we're going to look for on that segment is the middle point. Where would midpoint M be located? Well, if we think about rise and run for a moment, rise 1, 2, 3 boxes, up 4 boxes, right? Because this point A is up 3, because the ordered pair was negative 4, 3. So in our y direction, we're up 3. So if we have to rise to get up to B, its y value is 7. So from 3 to 7, we're rising 4 boxes for a rise. Slope, again, remember slope is rise over run. And we're going to review that in the next couple lessons. Our run goes from negative 4 all the way over here to 6. So we're going to run 10 boxes. So if we're going up 4 and over 10, well, the middle would go halfway. Halfway up is up 2. Halfway over 2, 3, 4, 5 is over 5. So the middle is going to be up 2 over 5. Is going to find midpoint M. Now that location is over 1 box, right, in the X direction, and up 1, 2, 3, 4, 5 boxes. So locate point M is at 1, 5. Now, if you need to pause the video, graph it for yourself to see it, that's what we get, right? And there's a formula to go along with this. So when we're looking at these ordered pairs, we had ordered pair A had an X value and a Y value, and then ordered pair B had a second X value. We call that X2 and Y2. So we have X1, Y1, can kind of see our little subscripts here. And then we have X2, Y2. So for the first ordered pair and the second ordered pair, you have 2 X's and 2 Y's. You're used to finding slope was Y2 minus Y1 over X2 minus X1. Okay, we all know that equation. But today we're going to add in a midpoint formula. So the midpoint, MDPT is my abbreviation, equals a big old set of parentheses. Okay. And what we're going to be doing for each set of parentheses is we're going to be finding their average. So from a negative 4 in the X direction to this positive 6, we found halfway in, right? We went over 5 boxes from negative 4. So how to find an average, just like your other classes, you add your values and divide by how many values you have. So your formula is going to read x1 plus x2 all over 2. And for the y values, you take y little 1 plus y little 2 and divide by 2. So the reason we need the formula, we could graph it all the time, but if we have crazy points like this, 25, 15 and negative 13, 65, we're going to want a formula to kind of to make the process go a little faster. So exercise 4 here reads, find the midpoint of a segment connecting the points 25, negative 15 and negative 13, 67. So here's an x value, it's the first one, and a y value, the first one. Here's the second x value, x2, second y value, y2. So the first x value is 25. Here's negative 15, negative 13, and 67. So we're going to start with the formula. Reads x1 plus x2, divide them by 2. Then we're going to take the y1 value plus the y2 value, take that sum, and divide by 2. So it's important that we're careful putting these into our calculator, and I'll show you that in a second. But our substitution, is going to go like this. The first one, x1 value is 25 plus the second x1 value is negative 13, divide by 2. And the y values go negative 15 plus 67 and divide by 2. My handwriting there was a little bit off. Let's try that one again. Negative 15 plus 67. Now, when you go to put this in the calculator, we have to be careful. If I put in 25 plus negative 13 divided by 2, your order of operations is going to give you a decimal. What we really want to be doing is take this sum first. Well, 25 minus 13 should be 12, if some of us can do that in our head. 12 divided by 2 gives us an x value of 6. So when you go to put these in your calculator, you might want to put parentheses around the top of your fraction, the numerator. So 25 plus negative 13, then divide that sum by 2. All right, we should get 6. The next one is negative 15 plus 67, close parentheses, divided by 2. So we want that sum divided by 2 gives us 26. Okay? Because here, when we subtract 15 from 67, we do get 52, and that divided by 2 is 26. So that's the ordered pair for the midpoint. So here's your x value of the midpoint and the y value. So if we think about this a second, 25 over and 15 down would be 1 point. Negative 13 over and 67 really, really tall would be that other point. That 626 would be the midpoint, a little bit over and pretty far up. So this is a smidge of a sketch to represent these three ordered pairs. But again, your midpoint formula is to take the x values, add them, and find their average. So divide that by 2. Take the y values, add those, and divide by 2. Moving to the next page. Sometimes they try to trick you. Okay. I'm going to come back up to this box here in a second. I'm going to look at number 5 and ask us to kind of think about this a second. Because the wording is, we have to read carefully. M is the midpoint of AB. So think about your picture here. If A is here, M is the middle, B would be the other end point. So A and B are your end points. B is in the middle. So if the coordinates of A are negative 2, 3, I'm just going to trace over my x-axis and my y-axis. So I remember where the middle there is. So the coordinates of A are negative 2 up 3. So when we graph, I want you to label. The midpoint is 1, 0. Where is B going to be? So if this is A, this is M, B has got to be down here somewhere, right? And what we can do is we can use our slope to find it. Well, from A to get to M, we're going to go down 3 boxes and over 3 boxes. So it's down 3 and then over 3 from A to M. Then we're going to go down 1, 2, 3 more boxes and over 1, 2, 3 boxes. So from A to find B, to have that distance be the same, we would continue the process. Then we could count it out. Well, that's 1, 2, 3, 4 boxes over and 3 boxes down. So point B in the x direction is 4 boxes to the right, and -3 moves us down. So that's our coordinates of B. Now, how I like to find that is what I call the rainbow method. So we always start with a point A, okay? And let's say that the ordered pairs of A are 2, 3. I'm making up a new problem to kind of help us out, not using the negatives here. Then point M they give you is 5, 8. We want to be finding point B, which we need those two values, the X value and the Y value. Well, rainbow tells me, how did they get from 2 as an X value to 5 as an X value? I added 3. So how am I going to get from 5 to my next B value? I'm going to add 3 more. So whatever we do to 1, because we're, again, adding 3 to X moves us to the right 3. So 5 plus 3 more would give us an X value of 8. Then we're going to find our Y value. From a 3 as the Y value to the 8 as a Y value, we have to add 5. Okay. Well, that moved us up 5, right? So now from 8, we have to move up 5 more to keep it the same. So the B value is 8 plus 5 more is going to be 13. So this is what I call, again, the rainbow method. We rainbow ourselves from X to X and then jump that again, find our second endpoint. Then we rainbow from Y to Y, and we add that same amount or subtract if we have to the second Y value. So number 5, we just did graphically. Number 6 asks it a little bit different. If I show you the rainbow for number 5, actually 6 is not a rainbow question. So let's look at here. So again, the point they gave us A was -2, 3. And we did do this graphically. So if you have graph paper for your homework questions, you can do it graphically. They gave us the midpoint is 1, 0. We're going to verify. So we already did this on the graph paper. We found 4, -3. I'm going to practice the rainbow method I just showed you here. How do you get from -2 to +1? Well, from -2 to +1, we moved over 3. So we add 3. How do you get from 1 to the new X value here? We're going to add 3 more. So 1 plus 3 more gives us 4. The Y values, we move from the 3 to the 0. So it was up 3. So we went down 3. So we subtracted 3 to get to 0. So 3 minus 3 gives you 0. 0 subtract 3 more gave us -3. So our ordered pair is 4, -3. So again, this is how I did it on the graph paper. This is how I used my little rainbow to write out the 3 ordered pairs. And again, that order is important. The first endpoint, A, goes here. The midpoint goes in the middle. And then what you're finding goes over to your right. Number 6, I'm going to kind of end with today. 7, we're not going to worry about. I might have even crossed that out in your packets. I don't remember. But looking at number 6, a circle O has diameter EF. So another shape we're going to look at this year is a circle. And we're going to draw in a diameter. So the diameter is from E to F. And how we name a circle O is its center. Now that center is the middle point on the diameter. So again, your center is the midpoint. So if E is at -3, 5, if we graph that, and F is at 4, -7, we need to find the coordinates of its center. So our midpoint formula says x little 1 plus x little 2 divide by 2, y little 1 plus y little 2 divide by 2. So if it helps you to write x1, y1 over one value, x2, y2 over the other, we're going to add our x's. So negative 3 plus 4 gives us negative 1. Sorry, negative 3 plus 4, and then we divide by 2 is our substitution. And then our y values are 5 plus negative 7 over 2. So I'm just going to add these in my head. Negative 3 plus 4 is 1. 1 divided by 2, our x value can be a half. You go half a box over on your coordinate grid. 5 plus negative 7 is negative 2. Gets divided by 2 is negative 1. So the ordered pair for center O in this circle, again, is a half comma negative 1. So we had 2 points on the circle, and we had to find the ordered pair for that, the center, which happened to be the midpoint across that diameter. Looking ahead to the classwork, please use the midpoint formula or graph paper to solve the following. Be sure to label the points to help understand what you're looking for. So here it's just asking for the midpoint, so you'll use your formula. Number 2, what are the coordinates of the center of the circle? Again, use a formula. So I left you some scrap graph paper here to the right to graph that out if it's helpful for you. Number 3 is where you'll use your rainbow if you want to give yourself a little clue. Okay, and again, if it helps to graph it out. So I'd highly suggest using pencil if you're using that graph paper. You can kind of reuse it for each question here. Try on your own number 4. Number 5 is like one of the first examples on your homework. And then the back page here is just a look ahead for an upcoming quiz. We're going to have a Unit 1 quiz the week of October 5th or the 8th, depending on if you're an A day person or a B day person. And you remote students, I'll let you know what's up with that. So the next couple of questions are some mixed review. Good luck.